So as we get into stoichiometry this week, one of the most important things that we need to understand when we're setting up stoichiometric problems is really the way that we lay it out and what kind of information we need to put down there. We're going to take, for example, the synthesis of ammonia from nitrogen and hydrogen, which is a 1-3-2 molar relationship. All three of these species are gases at standard conditions. I've laid out the molar masses for each right here. And so I've set up 3 sample problems with each one of these having nitrogen as our known reactant and then our unknown product being ammonia. And we can see how the setup changes depending on the value in which the known is given. You'll see here that I've made the unknown set to grams in all 3 cases, but I have different values set for the known value. As we've discussed already, stoichiometry is about resetting a mole ratio to deal with actual physical amounts. So the mole ratio in all 3 is our unknown over known, which is ammonia over nitrogen. We always use the balance equation for this central part of a stoichiometry problem. Since all 3 of the unknown ammonia products that we're looking for are set to grams, notice that I have a conversion step here that multiplies the molar amount of ammonia by its molar mass. However, because the known amount in this problem is in moles, this is in liters, and this is in grams, we have to evaluate whether or not we need a conversion step here, and if so, which one we need. Because for 18.4 moles of nitrogen is already set to moles, there is no need for a conversion step here. We simply multiply it times unknown over known, and then we set the moles to grams by multiplying by the molar mass. Here, the known value is 145 liters. We're assuming this is at standard conditions. So we need to set it to moles by dividing by the molar volume of the gas, which is 22.4 liters. And this applies to all gases that are being under standard temperature and pressure: hydrogen, oxygen, methane, natural gas, you name it. Here we have our known set to grams, and thus we need to change it into moles by dividing by the molar mass. So the real story here is that even though we are looking at the same known and the same unknown, and that the unknown in all 3 cases is going to be asked for in grams, the known has 3 different values, and thus this step has to be viewed differently according to what has been given to us. And as always, we do well to evaluate our setup to see if it is cancelable, which increases our confidence that we've set this up. As you can see here, moles of ammonia cancel, and moles of nitrogen cancel. In this problem, we have liters of nitrogen cancel, moles of nitrogen cancel, and moles of ammonia canceling. And then here we have grams nitrogen canceling, moles nitrogen canceling, and then moles ammonia canceling, thus leaving only the desired value, grams ammonia, that is uncanceled. This type of math logic is applicable to all fractional multiplication that you may encounter in physics, in a business class. It doesn't matter. This is part of the basic way that math works. It not only helps simplify things, it also helps you figure out how to set up a problem and check to see that you've set it up correctly.